Hello everyone, welcome back, and today we're going to be going through the reballing of a PlayStation 4 APU BGA chip, and that is basically the combined CPU and GPU for the PlayStation 4. And this particular machine that we're working on today is a blue light of death. Basically what happens is you hit the power button, it beeps, it flashes a blue light up here for a couple of seconds and then powers off. So we've done a little bit of preliminary testing on this machine. We've reseated the power supply and things such as that nature. We've removed the hard drive. We've tried to get it into safe mode. None of that is having any effect. So the next step now is to have a go at reballing this APU chip. So today we're going to have a look at that. I've got a bit of a temporary setup in my workshop upstairs. Which is my spare room. I've not managed to sort that out yet, so it's not looking the tidiest or in the best sort of shape at the minute. Still on my list of things to do. And this is going to be using my old Panasonic TZ7 on a tripod for the video capture during this process. So it's not ideal, but it should suffice, certainly for the time being, to allow us to go through a little bit of this work, so we can go through it together and we can see exactly what's going to happen. So, unlike most other videos of this sort of nature, we're not going to go through this, at a million miles an hour with a load of techno music dubbed over the top. We are going to go through this step by step, and we're going to explain what we're doing along the way. So hopefully you can learn a few bits and pieces if this is something you want to do yourself. This is all completely self-taught as far as I go. I've not studied this in any way, shape or form. The only studying that I've done is literally watching probably hundreds of hours worth of this sort of stuff on YouTube and reading around a couple of the more technical sort of forums for this kind of work. So, any bits, I started at the bottom and worked my way up as far as this sort of skill goes. So anything that I've sort of learned that I felt helped me, I'll explain along the way. And save you, hopefully, the hours that I had to spend learning this sort of stuff and working things out for myself and filling in the missing bits and pieces, which enabled me to go from wrecking things to actually being a capable BGA rework technician, if you like. So, if I can help you out and save you, a couple of dead bits of kit or, a good few hours worth of research and working this sort of stuff out, then this video is going to be worth it for me and hopefully for you too. So it is an interesting process. So what we're going to do is we're not going to go through the strip down of the PS4. We'll do that some other time. So we're going to pick this up once we've stripped the machine and we have the motherboard out of the console and on our bench, and that's where we're going to start from. So we're going to go right the way through this. We're going to go through the entire process from start to finish. So we're going to start, like I say, with the board out on our desk. So we're going to prepare the board, so we're going to tape it up. We're going to go through what parts, what regions of the board we're going to tape up, what we're going to use to tape it up. We're then going to go through setting up our rework machine. So making sure that our board is properly supported while it's on the rework machine. The things we can do to facilitate that. We're going through setting up our temperature probes. We're going to skirt around the actual profile side of things for temperatures and things like that. We will touch on it, but we're not going to go through it in any great detail because that's something I plan to do in a later video. Plus it varies from machine to machine. So we're just going to go through the actual BGA rework process today. For the record, my machine is a Joviari 8500. Superb machine. Sort of like price performance, it's highly recommended. It is about 1,600 quid here in the UK. Certainly not the cheapest, but it's certainly one that's highly recommended by myself. I have used a couple of the cheaper machines myself, and this is by far and away the best machine I've ever used. And without spending sort of really silly money on a machine, this one is the one that will get you the consistent, reliable, predictable results, and that's ultimately what you are aiming for with this kind of work. So we'll go through a bit on how to use that machine as well. So if you are looking for one of these machines, then as I say, you'll be able to see what we have to do with it. and you'll be able to make your own mind up whether you think it's worth spending that sort of money. But once we've done that, as I say, we'll go through lifting the chip. We'll then clean the board, we'll clean the chip, and we'll show you exactly what we're doing there. We'll then reball the chip, and then we'll resight it on the board, and we'll reflow that reball chip back to the board and reattach. And then we'll nail it all back together, and we'll see if it lives again, and hopefully it will. So, you know, hopefully you're going to learn something out of this today. As I say, we're going to go through a few tips and tricks and hints that I've sort of picked up along the way. The things that I've tried out myself that work really well. You know, and we'll touch a little bit on the kit that we use. So as I say, for the reballing machine, the BGA rework machine, today we're going to be using a Jovi RE8500. For our solder station, we're going to be using a Jovi iSolder 40, which again, you know, I've used a lot of irons and soldering stations, and this is by far and away the best one I've ever used. It's not expensive, you know, it's about £130 again in the UK, which, you know, isn't a lot of money for this sort of thing, but it is absolutely superb. And gives me some great results. And again, you know, we don't lift pads, we don't lift, you know, we don't tear traces off the board of the BGAs with this machine, because the temperature control is incredibly accurate, and the sort of it's very, very stable. So you know, it really does make doing this work a lot easier when you've got the quality tools to do it with. If you want a quality outcome and a quality repair, you need to get the quality tools and materials to facilitate the job. So that is what we're going to go through today. So we're going to pick up in a sec with the board out of the machine, and then we're going to start to tape it up and prepare the board for rework. So I'll see you in a sec. Well, hello there everybody, and today we're going to go over the reballing of this APU chip on this PlayStation 4 motherboard. Now this one is a SAB001 board revision, so this is one of the later PS4 revisions. So there's not a lot of difference between this and the earlier SAA 001s. Some slight differences in the power regulation there has been pared down a little bit. So this is a slightly more power efficient model, but other than that, things stay pretty much the same. The major components are more or less the same between the two revisions. So the APU is the same, all the SCI branded Southbridge and secondary processors are the same, the GDDR3 chip's the same, the RAM's the same. So, you know, it's more or less an identical board, barring a few sort of like efficiency revisions. So today we're going to look at reballing this, as we say. So we're going to be lifting this APU chip here. So we've cleaned that off, and we're just going to see if we can get a little bit closer. So as you can see, that there is what we're going to be looking to sort out. So we've cleaned it off, and we're more or less ready to go on this now. So all we need to do is we need to protect the components around it, because obviously we don't want to be taking anything out that we don't have to. We certainly don't want to be you know, taking any unnecessary stress out on these RAM blocks or anything else. So what we're going to do is we're going to get a little bit of this here captain tape. So this is like heat reflective foil. So we're going to take some of that and we're going to just tape up around the edges of the RAM blocks, and then that should suffice, to be honest. So this is like I said, it's going to be a step-by-step sort of tutorial, if you like, on how to do one of these. So you are going to need a few bits and pieces which we'll go through, and as I say, if I can share a couple of tips and tricks along the way with you, then I'll be happy to do so. So like I say, we're going to get this captain tape here, and we're just going to start to tape this board up. So you don't need anything special for this. Like I say, it's just a roll of captain tape and a pair of scissors. So that's what we're going to do. So you don't have to do anything particularly special with this. As I say, it's just a case of applying the tape correctly. So Kapton tape basically is heat reflective tape, so this will stop any undue stress to the components that we don't really want to be heating up. So we just apply this tape around the edge of the APU and the other various bits and pieces that we don't want to be applying too much stress to. So we're going to do that on the front and back, so there's no really any point in watching me do too much of this. You've got the idea. So we're going to go there, around this edge, this edge, this edge, and then we're going to do the same on the underside. So if you want to come back in a sec, and we'll show you what we've done when we've taped it all. Okay, so on this bottom side then, let's have a look at what we've taped up. So we've taped around the edge of the BGA. So all these little dots you can see here are vias. So they go, they're basically through hole traces, they go right the way through all the different layers of the board. Those mark out the edges of the BGA. We've got a temperature sensor for the bottom side taped up there. And we've also taped up that little thing there. So underneath that metal plate, that is our HDMI encoder IC, which is responsible for outputting a signal from our video chip out and the audio, and mixes it and chucks it out through the HDMI port. So sometimes when you'll get a pulsing blue light or a white light and no video, then usually your culprit is the chip underneath there. But anyway, I digress. So as I say, what we've done is we've taped up around the footprint on the back and all those RAM bricks there, and as I say, the temperature sensor for the bottom side of the board go into our BGA reworking machine is taped up there. So the tip is making contact with the underside of the board. That's going to measure the temperature of the bottom side of our board during the rework phase. As I say, it helps to have more than one sensor on there, so most machines have a capacity for 2 at least. Mine has 5, but I only use the 2, one for the top, one for the bottom. So as I say, that'll make sure that we get a nice even distribution of heat through our PCB, which will mean that we can lift the chip successfully without pulling any pads off the BGA off the board, because if we pull pads off the BGA, it's game over. If we pull pads off the board, it can be salvaged, but it is a real pain in the arse, and we want to avoid that where possible. So this temperature sensor is a K-type thermocouple. So as I say, it's a piece of wire with 2 different metallic elements in there, and the resistance between the 2 types of metal in there is how the machine works out temperature, which is all clever stuff. It's above my head, to be honest with you, so I'm not going to bore you with any more of that. If we have a look at the top, so that's our BGA we're going to be removing there, our APU. So we've taped around the edges, so all these RAM blocks are taped up. There's lots of little surface mount components around the edges, very close to the chip. We want to tape all those up because they can move, they can slide, they can jump about. We don't want that. The other big thing is, of course, over here, remember to remove your cell battery there, because those do like to go pop if you don't remove them, and it's not a particularly pleasant experience. It chucks bits of metal and loads of nice battery acid and everything else everywhere, and it goes with a bit of a bang and makes you jump, so I don't recommend doing that. Speaking from experience, once or twice there when I started out. So yeah, don't forget to remove that, whatever you do. So we are ready to go here, so we're ready to mount up on our rework machine, so we're going to have a pop over there in a sec, and if you want to join me in a second, like I say, over there, and we'll go through what we need to do next. Right, okay ladies and gents, so we've got our board all secure there now, so that's all on the support table of our rework machine. So there's a couple of important things that you need to make sure that you do with this. The first thing is, of course, is that you want to make sure that your BGA that you're going to be reworking is under the centre of the heater on your, or the top heater on your BGA machine. There's a couple of ways to do that. Now, if you've got a machine like mine, you can see there now that we've got a laser pointer, and that points smack in the middle of where the heating element for the top heater is going to sit. So all you need to do is make sure that that little dot there is in the middle of your chip, and you are good to go. Unfortunately, if you've got a cheaper machine, you probably don't have one of those, so you're just going to try and play it by eyesight. Drop the heater down close to the board, make sure you get it centre, and then raise it back up. So either or, that will do the trick. So on this machine as well, we've got like a sliding table. So basically these clamps will move about independently of each other, which enable us to slot one side of the board into these little runners, and these little grooves down the edge. They hold the edges of the board. Now, I can't stress enough, what you really need to do with this is get yourself either a support jig, so you can buy them from eBay or BGA rework stores, where you can actually bolt through the various little screw holes around the edge, and you can bolt the board down to there, which sort of stops it from warping and bending in the centre, because when these do heat, the PCBs will flex. That is a bit of a problem, because if it flexes too far, what can happen is you can end up with where the chip doesn't sit flat, and then it starts to lean to one side, and then you end up bridging things, and it can also ruin the board and take it out of shape, and you'll never get it back. And if you never get it back, you never get it working again, and you're going to go and buy a new PS4, which is not what you want. So I can't stress enough, you want to make sure it's properly supported. The way I do it is I have an extra Jovi support beam for this rework machine, so that has a couple of adjustable stilts that you can see we just screw into these various holes all the way along. So what I do is, you want to make sure that this is as close to the BGA site as you can get it without actually blocking the footprint from the heaters. So you don't want it directly underneath the chip, because if you do that, your heat from the bottom side of the board won't get through to the underside of the chip, and as I say, what you can end up doing then is where the central balls might not be heated sufficiently, or the pads on the board won't be heated sufficiently, and you can end up ripping them off. As I say, you don't want to be doing that, because it's either a nightmare or it's game over for your machine. So you want to make sure that this is as close as you can get it without actually being anywhere underneath the footprint of the chip. And as I say, what you need to do then is you need to adjust the stilts underneath so that they actually support the board. And a good method of testing is to have a quick look underneath, and just making sure that those are making contact sufficiently with the board. If not, then you just need to wind them up or wind them down a little bit. And then what you should do, just to test to make sure that those are all in the right place, is give the centre of your chip you're going to be working on a press. So just push it down in the centre, not too hard, but just enough where you'll be able to feel any deviation. If it feels like the board bounces, or that you can sort of move it, and it kind of sort of wants to bend underneath the pressure you're applying, then you've not got your board sufficiently supported, and when you heat it, it will warp and it will move. So you need to make sure that you've got it sufficiently supported, and like I say, a quick light press should mean that you can't actually feel any deviation. It feels solid and it isn't going to move. Once you've done that, you're good to go, and then we can start to rework this machine. So as I say, on this Jovi, I'm very, very privileged to have this machine, to be honest with you. As I say, what we need to do now is we need to get our profile sorted out. So you might go, what's our profile? Our profile is our temperature curve we're going to use. So obviously we start off at room temperature, and we go up to the point where we get the board sufficiently hot, so we make sure that the heat absorbs all the way through the PCB and gets to the chip. And then what we do is we go up again, and we get it to the point where the solder becomes liquidous, and we hold it there for a few seconds. We lift the chip, and of course we stop the profile, and the heat gradually ramps back down to room temperature. So that process is your heat curve. Now on this machine it's completely programmable, and it's computer controlled and monitored. So on this machine it's more or less a fire and forget, which is very, very nice. On cheaper machines like my old one, my old APU, you don't have that privilege unfortunately, so you do have to keep a bit of a closer eye on the temperatures and just make sure that they ain't going too quickly. So if you heat the chip too quickly, you can end up with something called popcorning. Popcorning is absolutely no fun whatsoever. That is where moisture in the chip isn't removed sufficiently during the refill process, and what can happen is that moisture in the chip turns to steam and actually expands inside the chip rather than evaporating out, and what you can end up with is a rather nice bumpy effect on the top of your chip. If you do that, then it's game over and your chip is ruined, because all the layers in the layers of the actual die itself all merge together, push up into one another and internally short, and as I say, that is a game over for your chip. So on this machine, like I say, it's quite nice. It's not easy to do that with this machine, you've got to be fairly careless. With cheaper machines, like I say, where you've got a more manual control over it, it can be fairly easy, certainly if the board's been sat around in a fairly humid atmosphere for a while, so say in a cupboard, and it gets a bit of moisture. And do be careful, and you might want to bake your board for say an hour or so at a low temperature, around 100 degrees, something like that, just to withdraw the moisture from it before you go putting it on this machine. But as I say, we're okay. Quite a warm day today as well. This board hasn't been sat around too long either. So we're going to just go ahead and we're going to go and work straight directly on this board. So we've got it all supported. The thermocouple, as I say, from the underside, you can see it sticking out there, is going into our control panel, which is down here. So those little yellow plugs here are the thermocouples. So that's the bottom one. That's the one we taped on earlier. That's the top one. The top one sits up here. We're going to go through sighting that on the board in a sec. So on the actual display of our reflow machine there, you can actually see the main menu. So it's quite nice. So you've got Profile Manager. That's where you can create profiles and select profiles to run them. So those are pre-programmed temperature curves basically. And we're going to be using one of those. Manual control is where you basically set the temperature. Basically, you set the power of the heaters and then they ramp. And you basically got to keep an eye on it. We're going to be using that as well at some point. And we'll go through that. Settings, we're not going to worry about too much for now. We will go through another video of how to set up a profile on this machine and whatnot in a future video. But for now, we're not going to do that. We're just going to get on with this process. So down here as well, we've got buttons for the pump. So we do have an inbuilt chip picker on this machine. So it's got like a little vacuum pump with this vacuum pencil. We're going to be using that to lift the chip from the board once we've reflowed it. That basically stops our process and kicks the fan in, and that basically is the button that we use to select the various options, so that's the OK button. So what we need to do first is we need to flux this chip up, and then we need to sight our top temperature probe, and then we can get ahead and we can start to lift this chip. So if you come back in a sec, guys, and we'll carry on. Right, okay, so we have our board all secured there now. So what have we done so far? So we've taped everything off with Captain Tape, so that's all properly prepared now. We've got our board onto our rework machine. We've got our temperature probe for the underside in place and all taped up. We've got our BGA centered on our machine, and we've got our board properly supported, and that's all good and ready to go. So now we need to flux the chip, and basically the flux aids wetting and tinning of the solder pads. So in this case, what we're going to use it for is it encourages the solder to enter a liquidous state, which enables us to lift the chip easily without causing any damage to the chip or the pads on the motherboard. So today we're going to do this quite easily, and we are using Kingbow for this. So what I do is I get a little paintbrush. Now the best way of doing this, to be honest, is with a syringe, to be fair, because you can just inject it down the sides of the chip and underneath, because ultimately that's where we want it. But like I say, if you don't have a syringe, and in this case today unfortunately I don't, then what you need to do is a little paintbrush will suffice, such as this. Just load your brush up with a bit of paste on it, and then just run that down along the sides of the chip. So you want to try and push it underneath the bottom edge of the chip, and just repeat that through all 4 sides. So it can be a little bit messy if you get too much. But basically what will happen is, as this paste gets warm, so as it heats up, it will enter a liquidous state, and as I say, because we've sort of run it around the base of the chip, it will run underneath. A little bit on the top there. So yeah, so it's not the most ideal way of doing it, because as I say, you can sort of get it everywhere. Just going to get that excess off there. So what will happen now is we need to place our top temperature probe in position, so we have a fixed metal wand, if you like, on this particular rework machine, and that wants to go contacting the board a couple of millimeters away from the site we're working on. So that's there, and what we need to do now is get some fume extraction and just put it close to the site we're working so it can draw all the noxious fumes away, because this stuff is pretty nasty. You don't want to be breathing it in. So I can't stress enough really that you make sure you have sufficient ventilation for this. You don't want to be doing it in a closed room. You want plenty of air and ventilation around it. You don't want to be breathing this stuff in. I actually had a homemade extraction system using an activated charcoal filter and an old bathroom extraction fan. Is what I used to use. It did a job. It drew the fumes away outside. But now I actually have this this Weller proper fume extraction kit for this now, which I managed to pick up brand new for a decent price on eBay. So it's always worth a check if you're wanting something like this. But you know, please don't be doing this in an enclosed space, because it won't do your lungs any good at all. So we are more or less ready to go there now. So we're just going to power on our rework machine, and if we come down here and just take a quick look, so this is our menu now for our Jovi. So this is the control panel. So we've got everything in place now, so we just need to run the profile. So what we'll do is we're going to set the profile, and this is one that I've already pre-programmed in this machine. We'll go through the profile settings that I use and a bit more in depth on how to use and program this machine in a different video. So we're just going to choose an existing profile, and there's one that I have already programmed there for PS4 APU lift, so we'll select that. that loads profile in, and as we can see it's for lead-free solder. So we'll OK that. As you can see, the preheat is 120, soak is 200, the peak temperature, so that's the top temperature, going to reach 225, and it's going to alarm at 220 because lead-free solder typically melts around 218 to 220 degree mark. So at any point around there we're going to be looking for this chip to move. So that's all okay. So we're happy with that. So that is going to run. So we don't quite want it to run just yet, but it is loaded into memory there, and we're ready to go when we need. So if we just go back up here to our chip, as you can see, the little laser pointer there is centering our die. We're going to swing this top heat around now. If you do have this same sort of machine, then what you want to do is you want to lower this top heater down to position number 4. So actually I'm just going to come around the other side of the camera. So there's some little markings on the side of the machine to measure the height. I typically use position 4 on this machine, so that is what we're going to use here. And you can't really see that now, but as I say, everything is in place there now. I'm just going to do a little bit of adjustment on the position of our probe. There we go. So I'll just move you back slightly. See if we can move you down a little bit so you can better see what's going on. So you can see our chip in place there. Try and get some focus on it. There we go. So what we'll do now is we'll just run this profile. We'll move the fume extraction into place. Just check the positioning of everything, like our thermal probes. There we go. Okay, and we'll turn the fume extraction on. And we'll run this profile now. And we'll see how we go. So if we have a look back down at the Jovi, you see now we're preheating, and our top temperature probe, so TC1 is the temperature probe at the top of the board, TC2 is the temperature probe at the bottom. And there's our chip there, so we'll come back as we try to lift this. Okay, so now we're around the 210 degree mark, and you can start to see that our chip is getting nice and warm. The smoke you can see is the flux residue burning off. We're at about 220, so our machine's going to beep. What you want to do is just get the end of a brush and just push the bottom side of the chip, and you're looking for movement. There we go, so you can see that's starting to wobble there now. So we're going to lift away, and we're going to get our vac pump. I'm going to lift the chip away from the board. I'm just going to hold it into the fume extraction there just to pull the fumes away. As I say, this is pretty nasty stuff really, you don't want to be breathing it in if you can at all help it. And then I'm just going to pop that down. like a little heat sink from an old Xbox. And that just draws the heat out nicely. Just to kill the pump. And there we go. So that is the APU lifted. And our board there now. As you can see, has the chip lifted as well. So what we need to do now is get the board and the chip prepared for cleaning. So that's what we're going to do next. Right, okay, so next step is to prepare our chip for cleaning. So in order to do that, all we need to do is we need to place our chip into this jig, which we do. So basically they've got jaws on each side with some little indents cut out. You can see the corners there, so the corners of the chip just sit nicely into those two corners there. So we just offer it up and just turn this little screw until those sit securely around the edge of the chip. And if we check the sides, are level there, so as you can see the chip is nice and flat. So now it's flat and it's secure and it's not moving anywhere, we need to clean this chip off of any old solder. So there is basically a method to this. So what we're going to do is we're going to put a little bit of leaded solder on our iron, and then we're going to use that to run around the chip, and that's going to pick all the old balls off, and also tin the pads with leaded solder. And then what we'll do is we'll get the desoldering braid and we'll go around the edge of the chip with that. And what that will do is that will clear the pads completely of the old solder in preparation for placing the new leaded balls onto our chip. So what we'll do is we will start the process in a sec. I'm just going to plug my iron in. Okay, and we'll just power that on. Okay, so the iron is going to get up to temperature in a sec. Doesn't take it long. Okay, there we go. So iron is now on and up to temperature. So we're just going to start the fume extraction. First things first, we're just going to flux this chip up. So you want to give the chip a fairly decent coating of this stuff. We're going to clean it off at the end of this process anyway, so don't be too frightened of sticking a fair bit on there. Make sure there's a good even coating across the surface of the BGA. As I say, make sure your fume extraction is on and working. And once you've done that, you want to tin the end of your iron with a little bit of leaded solder. Just so there's a little ball forms on the end of your iron tip, and then run that gently over the pads of your chip. Now you don't really want to be making contact with the surface of the chip with the end of the iron, because that can lift pads from the BGA or cause other related heat damage, which is not good. Likewise, you don't want too big a ball of solder on the end of your tip, because if you do that, that will sap the heat out of the end of the iron quickly, which will reduce the temperature of the end, which will make it harder for you to absorb the old solder, or at worst it all sort of solidifies and sticks to the chip, and then you've got a bit of a nightmare trying to get it all off. So as you go around the chip and you pick the old solder up, it will contribute to the ball. So as I say, you don't need too much, just enough to make sure that the end of your iron isn't making contact with the chip. And if you see any sort of pads that look dark, or usually that's just oxidation from the lifting process as the old solder is removed. So if you do get that, just run your eye back and forth over those pads a couple of times, just so they take a little bit of solder, which will make the cleaning and reballing of the chip so much easier for you. There's one there, there's a couple there. There we go. So that's got the biggest part of the old leaded stuff off there. So our next job now is to use the desolder braid to finish cleaning this chip off. Now the key to this is quite simple, and that is, as I say, make sure you've got plenty of flux on the chip. As you can see there is a sufficient coating of it on our chip there. You want a tiny little bit of solder on the end of the tip of your iron, only the tiniest amount, and then you get your braid, make contact with the surface of the chip, put the iron onto there, hesitate for a couple of seconds, and then move it round. Now the mistake a lot of people make here is that they move the iron. You don't want to move the iron. All you want, the iron needs to be placed onto the braid, and then the braid, you move the braid. So you move the braid, you don't move the iron. The iron simply sits on the top of the braid and you drag the braid around. And you want to do that nice and slowly as well. If you go too quickly, you run the risk of pulling pads, or lifting pads from the BGA. We don't want that. Plus a nice controlled speed helps to absorb the maximum amount of solder. Now then, you don't want to do too much too quickly at this either, because what you can do is you can end up overheating the chip, which will destroy it, which of course you don't want to do. And once you've got your little bit of braid fairly saturated, just trim the end of it off, so you've got a nice clean part, and then just rinse and repeat. And you want to do this till you've got the surface of the chip clean of any old solder, and basically the braid should be clean when you lift it away. So you give it a pass, and then just trim your braid, do another pass, trim your braid, another pass, until basically the braid, when you lift it away, is clean. So there shouldn't be any solder on the braid. Nice controlled, make sure you hit all the pads. So you don't want to do too much at it, you don't want to overheat it, you don't want to put any undue thermal stress on the die. It's looking fairly clean there. The black bit you can see is the old flux residue, which shows the flux is breaking down and working and doing its job. It's lifting the contaminants away. Don't force the braid either, that is key. If it feels like you're having to drag the braid and there's resistance there, then stop. Just tin the end of your iron a little bit with a tiny bit more solder, or add a little bit more flux to your chip if there doesn't look to be enough on there, and then just go over the surface again and keep going. And eventually you should be able to feel no lumps or bumps or any deviation in the surface of the BGA. Should feel nice and flat. And once that is the case, as we've got there, that's nice and flat now. So that chip now is ready to be cleaned off. So there's a couple of things, there's a couple of ways you can do that. Either get a decent ultrasonic cleaner. It's not a jewellery cleaner or anything like that. Those don't really do the chip too much good. But a nice sweeping frequency ultrasonic cleaner is probably the way forward. That's on my shopping list of things to get. Unfortunately for the moment I don't have one of those, so what I have is an old sort of cup. I put some IPA in there. So this old cup here, just pop some IPA in there with a brush. So a decent quality ultrasonic cleaner is the way to do this, but those are quite expensive. As I say, it's on my shopping list of things to get. But for the time being, unfortunately, I haven't got one. So, but this does a good enough job. So we're just going to remove the BGA from this clamp. Using our chip picker. Doesn't look nice, does it? We're just going to pop that in the bottom. And then we're just going to use the fine tip of the bristles, the alcohol, just to sweep across the surface of the chip. And that'll take about 20 to 30 seconds to actually start to work. You'll start to notice already the colour of our alcohol there is changing. And all you do is light brush over the surface of the chip. Just keep rotating it. And eventually you'll start to see the actual dirty brown gunk starts to lift and the nice shiny clean pads underneath start to show through. So if you don't have like say a decent ultrasonic clean, don't use a jewellery cleaner or anything like that, or any sort of harsh abrasives for cleaning this. A little bit of isopropyl alcohol of a decent concentration and a brush in an old cup will do the job nicely enough. Like I say, if you are lucky enough to have a really nice sweeping frequency ultrasonic cleaner or something like that, then by all means use that. So we'll come back in a moment and we'll take a look at the finished product. Okay then, so as you can see there, once we've finished just brushing the surface of the chip, just pop it onto a paper towel and give it a quick dab off. The alcohol does evaporate fairly quickly in room temperature anyway, so as I say, you just give it a quick dab off with a paper towel, and you get something hopefully which looks a little like this. If we can get some focus on it for you, just bear with me. There we go, so you can see there now that all the pads are nice and clean. They all look nice and shiny. We're not missing any. So there's none that look dull. There aren't any that look like they're lifted or missing. We've got no black spots on there, which would denote that a pad is missing. So that is all looking really nice. So that is now ready for the next step, which is where we actually put the balls onto the chip. But before we do that, for completeness, we are going to go back to our motherboard now, and we are going to actually clean the pads off the motherboard of the actual PS4. So we're going to make sure that the cleaning process is complete on board and BGA before we go to the balling phase. So as you can see there now, our chip is nice and clean and ready for the next step. So we need to prepare our motherboard now, and that's what we're going to go and do. Right, okay, so now we're going to go back to our PlayStation motherboard. Here it is, and we're going to remove the remaining old solder from this board. So it's pretty much as we did on the processor. So we're going to apply some flux. Now there are a couple of ways of doing this, and depending on who you speak to, depends on which method they use. And some people like to clean the board straight away, so once the chip's lifted they like to get straight on it while there's still heat in the board, and actually clean the solder then. But I actually prefer to do it when it's cold, and the reason for that is I tend to find that the pads are more willing to lift when the board is hot, because they've already been sustained to several minutes of very high temperature, and sticking flux on and dragging braid and another hot soldering iron over the surface just seems to upset it and lift all the pads. Well, not all of them, but you know what I mean. It tends to be easier to lift pads than it does to actually let the board cool down and actually process it a little bit later on. So we've just fluxed it up there, and we're going to do as we did before. We're going to add some leaded solder. And actually, I've just forgotten to turn on my fume extraction, so I'll just do that. So hopefully you can still see the chip there. And we're just going to run across the surface. It's only very lightly, you don't need any pressure. As I say, you want the solder ball making contact with the surface of the board. You don't want the iron tip making contact with the board. So once you've got the biggest part of that there, what I also like to tend to do, to be honest, just in case you do get a bit of a solder splash, is just get a little bit of foil or foil tape if you've got it, and just pop it down just somewhere to pop any excess solder that you might collect along the way, rather than having to drag it back across the board and potentially drip it onto some components, because, you know, why give yourself more headache than you need. So now we've done that, we're just going to go back around the edge with the braid, and as before we've got a little bit of solder on the tip, so a nice clean bit of braid, a couple of seconds. And that is dragging, so I'm just going to add a little bit more flux. As I say, if you feel any resistance at all, like I say, just pop a little bit more flux on there. We're going to clean it off anyway. Some more flux, a little bit more solder on the end of your iron. Another touch of braid. You see there now, that's got more willing. To move around there. So as you go and you saturate your braid, just trim it off, because saturated braid doesn't absorb any solder and it's just more likely to grab. If you feel as though there's any resistance whatsoever, then just stop. Just make sure everything's nice and clean. You don't need a lot of pressure for this, just light pressure. I'm just going to trim that. Now, to begin with, this board was being a little bit stubborn. It didn't seem to want to clean up. It tended to was trying to grab, which doesn't normally happen, to be honest. So as I say, you know, the important thing is just to be patient. If you do find that, you know, the board's been a little bit awkward and it's not quite cleaning up the way you'd hope, and like I say, you know, just add more flux, a bit more solder, clean your braid. So light pressure with the iron, move the braid. If you feel any resistance or snagging, then stop, don't force it, just lift the braid away with the iron attached. And just reassess and continue. As is appropriate. So eventually, as you can see, our braid there is fairly clean. There isn't much more coming off that now. So that's looking pretty good to go. So what we're going to do now is get a bit more alcohol, lift our foil away, so once you apply it, it's going to take 20 to 30 seconds just to start to break down the old contaminants, the old flux residue. Once it's clean, just get a paper towel or you know, a wipe. Preferably a lint-free one if you can. And just give it a wipe over. And then just inspect the surface. If you see any pads that have still got solder, or it's not completely flat, then just go back over that area that's affected. Just clean it off again, until eventually you get all your pads nice and clean. But in this instance, like I say, when you're running the brush over the top, you shouldn't be able to feel any lumps or bumps. The surface of the BGA site should feel nice and flat. Hopefully this one does, so we're just going to use a paper towel. I'll get another dab of alcohol. And just rub the paper towel across it, and as you can see, not very pleasant, is it? You'll see why we wear gloves for this now. Okay, yeah, so just had a quick look over that now. That's nice and clean and flat. We've got no lifted pads, no lifted traces or anything of that nature, so that is a successful cleaning. Just going to try and get you a little bit closer. you go. Right, okay, so now we're going to go through what I think is probably the hardest part of this entire process, and that is actually reballing the APU. Now when I first started out, this was the hardest bit. This was the bit I just couldn't grasp. So I'm going to give you a few pointers in which sort of made it click for me, and hopefully it'll do the same for you. So of course there's no point in starting this process if you can't get the chip to reball. And I always used to end up where they'd merge on the pads, or they'd run away, or you know, you just end up with a big mess, and you'd sort of have to try and reball it 4 or 5 times before you got a workable result, if you like, and that's just not really appropriate because it's going to take you too long to do it, and it's also going to thermally stress the chip, which of course you don't really want to be doing. So I have a few tips that hopefully are going to help you out here. So the first thing is important, and that is to make sure that your chip is completely clean when you start this. So the best way of doing that is to ensure that you clean all the old solder from the pads before you start, and you make sure that you wick it sufficiently and that your chip is nice and flat. You can just run your finger over the surface. It needs to feel lovely and flat. If it does, and you've cleaned it off, and you give it another feel and it still feels nice and clean and flat, great stuff. You can start the next step on this process. So like I say, you want to hold it up to the light, and you want to see, like I said, it's nice and flat. There's no lumps, bumps, deviations or anything in that surface. And providing you can do that and it all feels good, then you're ready to go. So in the light of the window, I can see that that is nice and flat. I don't know if you'll be able to catch it on the camera. Oh yeah, there you go. So you can see there that with the light, there's no lumps, bumps, deviations. Everything looks nice and flat and clean, and that is what we're after. So now we need to ball this up. So what's the best way? Well, you're going to need one of these. This is a reballing jig. So this thing will enable you basically to hold the chip central in the jig, and then you're going to need one of these. This is a stencil. So this basically is a flat thin sheet of metal with loads of little holes drilled out, and each of those holes corresponds to a point on your original BGA chip. And basically the idea is that when that's sat in the middle, all the holes in the pads line up, and you can put the balls on and they all fall nicely onto the holes, and away you go, and it's supposed to make your life a lot easier. But there are 1 or 2 little tricks to this, and there are different ones you can get. I mean, this one is a fairly straightforward thing to use. As I say, it's on a worm screw. The 2 ends move in and out together, so your chip will always sit central, and this sits over the top of your chip like so, and all your balls fall through the holes onto the pads, and you lift it off and away you go. So it is nice and easy. The other alternative that you do have, I've got a hole in my glove. I'm going to have to replace that one, I think. The other alternative you've got, I will show you in a sec, and that is one of these. Now this one is a slightly different sort of setup. Now then, I don't have the handles on this one, and you'll see why in a sec. But basically there's a handle there with like a rubber grip on it, and so that looks like that. So that sits on there and screws on, and then there's another handle that goes on the other side, and basically you'll see that these are spring loaded, which is quite nice. So you get a stencil which sits in the top of there, and I'll see if I've got one. Yes I do. That sits over the top of your chip there, and the same sort of premise applies. This one has a slightly more flexible clamp setup, so these 4 clamps move independently of each other, and then once you're done, basically you get all the handles and you push it, and the spring loading sort of pushes the base away from the top and the chip, and it all separates up really quite nicely. Now when I first started out, I thought that would be the easier thing to do than using one of these, because one of these may prove a little bit of a nightmare, because of course you've got to lift it off manually, whereas with that you can just push it down and all 4 sides move down at the same time. It turns out that actually I find these easier to use, and I'll go through why in a sec. So I'm just going to change the glove with the hole in. one without. Okay, so basically we have our chip there and it's all nicely aligned in our jig, and if we notice that in the jaws there it's nice and flat and level and it isn't sticking up at any point, so that is now good and ready to go. So you'll notice that on the pattern on the APU, on the PS4 APU anyway, the pattern is irregular, so it's asymmetric, so it's not the same on both sides basically. So you'll notice that these pads on this side are different from the pads this side, which means that this stencil will only align one way. Some chips have a symmetrical design on them, so they're basically identical on each side. So some chips you can literally put the stencil on any way, shape or form that you like. On this one that's not the case, this has to go on a certain way around. So you'll notice that our lines, so our pins there on our stencil line up one way with the pads on the chip. So all we're going to do is that is going to sit over the top. Now make sure your stencil's aligned before you do anything else, because if you flux this chip before you make sure your stencil's aligned, you're just going to make life awkward for yourself. So the easiest way to do that is to actually get your head over the top of the stencil and just check that all the pads line up. Now in this instance you'll see that that isn't the case, that doesn't happen. So you can usually see this best out of the light, but you can't really see much in the way of silver pads. In fact you might not be able to see that on the video, but the pads aren't lining up. So what do you do if the pads don't line up? Because they, they usually do take a little bit of adjustment. All you do is you slacken the bolts around the edge of your stencil, and basically this top plate is essentially a sandwich, so your template or your stencil basically is sandwiched between these two plates, there and there. So the stencil sits in between, and take these 4 bolts off, change your stencil, bolt it back down. So once it's loose, you can actually push this stencil 4 ways, so in, out, up, down, until you line your pads up. So that's what we're going to do here. So that goes back on there, and we basically just push this around until we get everything lined up. Now I'm going to be honest with you, the pins on this stencil in particular are brilliant, and what I mean by that is they don't perfectly line up, it is a little bit out. And you do tend to find that, to be honest. Very rarely do you get a stencil which is perfectly lined up. Now there are ways of combating that. Just get it somewhere close. That's what I tend to do with this one. So you'll notice on some of these, like I say, the holes, they're close, don't get me wrong, but they don't line up perfectly, which is fine. They don't have to be absolutely perfect. As long as they're as close as you can get it, it doesn't really matter. We can adjust things later on, and I'll go through that with you in a sec. But okay, so that's all lined up, and I've tightened those down. Like I say, I do have a little trick later on to make sure that we can get those as aligned as possible. So they're pretty close. That is pretty close. That's as close as we're going to get. I don't know if you'll be able to see on the camera, but we'll try it. If you can see any sort of metal pads there. Can't really see on the viewfinder on the camera, but this might become more apparent on the computer. I'll view it in full resolution, but you can see, well, you might be able to see, you might not, but all those little silver pads now on the bottom of the chip are showing through the holes on the stencil. As I say, not perfect. This particular stencil isn't perfect, unfortunately. As I say, they are ever so slightly fractionally out, but that's not going to cause us too much problem. So once we've got our stencil aligned and our chips in place, what do we need to do next? We need to flux it. So we need to flux the chip. So we're going to remove our top stencil. Now then, this is, like I say, this is the key to doing this process correctly first time, every time. This is the bit which will determine whether you have a successful reball or you don't, and you end up having to do it again. This is the bit I never used to be able to grasp, right? Okay, and the secret is how much flux you have on the surface of that chip. The answer is you want next to nothing on that chip. Literally, all you want is to make the surface look shiny. That is it. Any more, you've got too much. And I'll show you a perfect way of getting just the right amount on there. So you'll notice on some videos, people will be sat there and they'll be absolutely streaming, squeezing loads of flux out of syringes onto these things and wiping it over, and that's just a waste of time, and it's a waste of flux, it's a waste of resource. So what do you need to do? Well, I'll tell you what, whether you've got a syringe or have a tub of stuff like this, all you do is load your brush up with a bit of flux on it, like that, and then just wipe it over the edge. And really, like I say, you need next to nothing. So all I'm going to do is cover the central square with a reasonable amount. Okay. Once you've done that, brush to the edges of the chip, and brush it to all 4 sides. So all we're going to do is we're going to brush that to the edges of the chip. And like I say, you know, you might look at this and think you've not got enough. You know, earlier on when we were cleaning things, we were, you know, we'd more or less drowned the chip and the board in flux. You know, we haven't got next to nothing on there. How's that going to help? Well, to be honest, there's too much on there, which might come as a surprise to you. But anyway, so once you're happy that you've coated every pad quite nicely in flux, you know, and you've brushed it and it's fairly flat, but you're happy that you've got a nice even coat there. If you balled that, you'd be redoing it again, because basically there's too much flux on that chip and it'd all roll, all the balls would roll together, and you would end up with a nice mess to have to clean out later. So what do? Well, this is the secret for you. Get an old SIM card or an old credit card or something, you know, like one of those little plastic cards of that nature. So a credit card, debit card, old SIM card, something like that. Now I do have one around here somewhere and I don't know where it is. There it is. Found it. Okay, so I use this one here. It's half an old business card. And you get this, the edge, and just scrape it along the top, and you'll notice maybe at the edge of that card is absolutely covered in excess flux. So all you do is wipe that off, do it again. You want fairly even pressure, not too hard, but just enough to scrape the surface of that chip, and then turn it around and do the same in the opposite direction. Turn it around, do the same in that direction. You get a nice even coat across all 4 sides of the chip, and if you go around the edge, so just get the edge of the card and run it around the edge of the chip. So if you face it up, so just angle it upwards and then just run the card around the edge. You'll notice again, they get more excess. So if you notice excess on the edge of the chip once you've done that, you had too much flux on there. This side is the first side, this is the first side we scraped towards, so that, as you can see, whoa, look at that. And all that is just going to give you misery, because if you've got that much excess flux on the surface of your chip, your balls aren't going to adhere to the surface, they're not going to adhere to the pads as they should do, and they're just going to roll together and merge and give you nightmares. And I could never grasp this when I first started doing this process. I could never understand that is the secret to a successful reball. So, and even now I'm continuing to scrape it. So once you've gone around the edges and you've got the excess, repeat the process again. So again, around all 4 sides, wipe the card after each pass. And again, and again, and repeat the run around the edge. And we are basically going to repeat this process some more. And I'm just going to run back around the edge one more time. And back over the top. And if you take a close look now around the edge, you'll see that there's no more excess gathering at the sides or around the edges at all. And if we look in the light, basically you should be able to see that the surface is nice and flat, there's no ridges, no runs in there. The surface isn't coated with flux, it just looks wet. So if we look in the surface, you'll see there it's fairly even layer, fairly even coat. It isn't covered, and it's nice and flat. And once we've got that, if yours looks something a little bit like that, then you're going to be fine. So what we do then, get a stencil, make sure it's aligned, make sure that if you have used it before it's nice and clean, that there's no sort of excess flux on there from any previous jobs. If there is, just clean it off. Make sure there's no lint or dust or anything that's blocking the holes, because if there is, that's just going to end up on your chip and it's just going to make your life a nightmare. Having to pick up fibres off things, and you know, why make your life any harder than it has to be? So you line your stencil back up and just check the alignment of the pins again. Make sure there's somewhere close. Those are perfect, and now you're ready for your balls. So on this particular instance, well, so you can get these from anywhere really, eBay or BGA suppliers. These are PMTC, it's a profound material technology coat balls. These are really high quality solder balls. These are perfect. There's 250,000 in there. You can get them in smaller lots of about 25,000, sorry, 5,000. 25,000 pot will run you about £5. These were about 20 for these, so it's not a bad price, is it? Considering these will do you now. Be careful when you take the lid off, because they are they do respond to sort of magnetic, sort of static and things like that. So the plastic liner in the lid, for example, seems to attract them quite nicely. So be careful when you take the lid off, because they will go everywhere otherwise. So give them a quick shake before you take the lid off. That just encourages them to separate on the surface, and then just pour them on. Literally just pour them into the stencil. Now then, try not to go too mental, because ultimately, you know, you don't want to waste these balls really. But you know, when you got a good even covering in the pads and a pile in the middle, you literally just pick the stencil up, make sure you grab the top and the bottom, and just shake it around. So you get all the pads on the surface of the chip covered, and then shake it off. Now there's usually a channel, if you can see there on the bottom of the stencil, that the excess balls can run into, and usually the side of the channel has is like a little sort of rampway, so you can use that rampway to run all your spare excess balls up onto, and then back into your pot. Now the reason I like these big 250k pots as well is because they're nice and big, and they're easy to sort of run your excess balls up into. The smaller ones, now I do have a 25,000 pot, 25,000 ball pot there, as you can see, a hell of a lot smaller, so you've got to be more accurate when you're pouring your balls back in, otherwise they go all over your work surface and potentially onto all your boards that you're repairing and everything else, and generally just makes a bit of a mess. And you end up with loads of leaded balls floating around all your work surfaces, and that's not really what you want. So you'll notice we do have a couple of excess balls kicking around there and around here, so all you do there, get a pair of tweezers, either a pair of tweezers or a fine brush or something like that, and just knock them out of the way. trying not to take out any balls that are in the holes. If you do, you know, you can just replace them, but you know, there's nothing more frustrating than having to go around and spend 5 or 10 minutes putting balls in holes. Just be delicate with it and just brush the excess away, and then I'll just run down into the edge of the stencil. Now, and this particular part of the process is the same whether you've got one of those spring-loaded jigs or whether you've got one of these. The spring-loaded one is a 90 by 90mm stencil. This one's an 80 by 80. So, to be honest, it's usually good to have one of each, because some stencils you can only get in one size for some reason. The more common ones you can get in both. But if you have got any missing pads, just fill the balls in. Like I say, any excess, just knock them out of the way. If you have got a small fine brush, it does make this bit easier. If you haven't, a pair of tweezers and a steady hand will do it. So once you think you've got them all, just make sure there's no sap powder of the surface and they're all sat nicely in the holes. And as I said, I've missed one. To be honest, you can usually tell if there's any missing or stuck to the pads better out of the light. It seems to become more visible somehow. Now I'm going to give you a trick, because if you do get some where the stencils are slightly out, as I said on this one, the holes for the stencils are slightly out of alignment on this one, so the holes don't line up perfectly with the chip. Now when the holes are full of balls, you can't see that alignment anymore, so basically the only way is usually to lift that off, and if they're all out of alignment, then you're going to spend the next quarter of an hour lining things up, and that is no fun. It's certainly not what you want to be doing. So what I tend to do is just take a ball out of each corner of this chip. So on each of the 4 corners I'm just going to remove one ball out of the corner of this stencil. It doesn't really matter which one you do, just pick one and pick it out. Move it in. And move the excess balls away. So you've got one ball now missing in each one of those corners, and you can see the pads perfectly through those balls, and you'll see which side isn't lined up properly. So all you do is there's a tiny bit of play in these stencils. Just nudge it round till you've got things nicely aligned, and then lift this stencil off. Now the best way of doing that, again, if you've got one of these spring-loaded jigs, the blue ones that we saw earlier, they are a bit awkward, those ones, because you tend to be able to push down on one side of the chip. Now if you push down too hard on one side and the other, you end up pushing one side back up into the stencil, and it can sort of move them and merge all the balls together, and you are going to have a nightmare for the next quarter of an hour tidying things up. You need a steady hand and you know, apply even pressure across both both handles when you push down. These, believe it or not, are easier, because all you do is you peel it back. So you lift the stencil up on one side and then just rotate your hands. That's all you do to lift it up, so from flat to vertical. Once you're away from the surface, once you're away from the surface of the chip, by all means then just lift it. But whatever you do, when you move this back, don't lift, because if you lift it back at the same time, you'll end up knocking your stencil into all your balls and moving them all out of alignment again. So I'll show you what I mean in a sec. So I'm going to align the end with the ball pit, if you like, for the excess balls down towards the bottom. Because if you do it the other way up, once you lift this up, it's going to run back, and all the excess balls are going to run back over your stencil, and they're going to make a mess of your chip. So, you know, just little things, you know, and it might seem like common sense, and much of it is, but you'd be surprised, because you're focusing so much on what you're doing and getting this right, that it really is very simple to get it wrong. So, as you'll see there now, we're okay. The ball pit's this side, so it's facing me. And I'm just literally, you'll be able to see from this angle what I mean with my hands when I say you don't lift it back. You don't pull it back towards yourself and lift it. You literally just lift it till you're clear, and then you can pull it backwards. So you'll watch and you'll see the balls peel away from under the stencil. So this is all you do. Once you're clear, you can then pull away. And hopefully, as you can see there, that looks nice and clean, which it does. The biggest part of the pads all look nicely aligned. There's not too much there. It's not woefully out. As I say, the back edge of that stencil is slightly out of alignment with these pads. Not by a long way, not by enough to give us a headache, but by enough just to sort of like make it a little bit awkward when you're lining these up. So the next thing to do is just to make sure, you know, give it a visual check that, oh, you've got all your balls. Now, we do have one missing, which I can see is currently stuck in my stencil, which is okay, that's not a problem. Just get a spare ball on the end of your tweezers and just drop them on. Now, of course, we do have the 4 missing that we used to remove for aligning this thing. As I say, it's not normally something you need to do, but if you are aware that one of your stencils is slightly out, or it's not quite as accurate as you would like it to be, then it's always worth just removing a ball in each corner, so you can just keep an eye on the alignment. As I say, it is ever so slightly out on this one. Like I said, now then, the thing with these things is that they don't have to be exactly on the pads, because surface tension will make sure that the balls will pop onto the pads quite happily as long as they're somewhere close, but you don't want them touching other balls because they'll merge. You don't want the balls too far off the pads, otherwise they may run off the pad and not adhere to the pads, and then they don't set, but they just sit on the mask of the board rather than on the pads, and then you've got to start messing about with tweezers and putting them back in alignment. It's no fun. Any that are sort of like really out of alignment, you can just sort of knock back in with the end of a tweezer. They look okay to me. So as I say, you're always going to get one or two that will move slightly out. So any of those you just want to pop back on. Fortunately, there's not a lot you can do about that. It's just one of those things. A couple of minutes here is time well spent, and having to clean off your chip and redo it. Right, okay, so I've just spent a minute or so there, just off camera, just making sure those balls are nicely aligned on the chip. So I'm fairly anal about them sort of things. So those are nice and lined up now. So now that we've got the 4 balls that we took off earlier, just to monitor the pads in the corners, all back on, and we've had a look over the chip and we've made sure each pin has a ball on it, there's no excess balls on there, they're all nicely, sort of fairly closely aligned to the pads that they're going to be adhered to anyway. We're good to go and attempt to reball this. Now, the easiest way of doing this, to be honest, is either to get a decent thickish piece of hardwood, or something that you can just sit the chip on. What you don't want to do is put this on your rework machine and attempt to reset the balls on this. There's a simple explanation for that one, because basically these clamps in the corner here basically grasp the die around the edges. So what it basically does is it acts like a massive heatsink and draws all the heat away from the die, which makes it a real pain and a nuisance to actually set the balls on this chip. And what you tend to find if you do it with this particular one is that the balls in the corners don't actually set, which is a nightmare, because then you've got to sort of unjig it all and then sort of line everything back up again and put it back on your rework. It's just a nightmare. You don't want to do it. So either find a decent board, or an old PCB, or just something to support the chip on while it's on your machine. What I do, and this is the reason why my other Reball jig doesn't have any handles on it, because they're plastic, is I basically sit my chip on the edges of these 4 standoffs there, and they don't sap any heat away from it at all. It's nice, it's metal, it's nice and hardy, it doesn't melt, and it coats really nicely on the rework station. Like I say, it doesn't sap any heat away from the chip. So it's nice and easy just to sit it on there and then put that on the machine, and that's what we're going to do now. So in order to make sure that you don't actually move anything that you shouldn't be moving, this piece of tape here will become apparent in a sec as well. That is there for a reason. So in my instance, I'm going to get my chip picker and just slacken off one corner of this. I'm just going to twist the screw just so it releases the tension from the edges of this die, and then I'm going to get one edge of this chip picker under the corner of this chip, and just come back, get it central, and then just try and lift it up. Carefully does it, and just align that. Doesn't matter if you don't get it perfect, because you can always just knock it into alignment. So you do have to be slightly careful of this, because it is easy just to flip it or chuck it upside down, all of which is misery. A bit of patience and a fairly steady hand. Once you've got it somewhere close like that, you're good to go. Now just give it a quick look and make sure that it's flat and it's not going to fall off there. That looks good to me. So we can move our old stencil out of the way. Hopefully we're done with that, and we're not going to need it back for this particular chip. And then just check the pins, haven't rolled off and you've not caught any, because let's face it, it is easy to do. And this is sort of like your last chance saloon, just to make sure that all your points are aligned and they're not going to bridge and they're not going to roll off or wander. So this is what you want to do. So you just align this up. So they all look fairly well lined up now. So our next job is just to put this onto the view workstation, and then we'll put them on and we'll go there in a sec. Okay, so basically all we've done there is we've removed our motherboard off the jig, and then we just popped our Reball chip there just underneath the heater on the Jovi. So if we just I'll try and take a closer look here, try and get you some zoom where the focus doesn't go too mental. I hate the autofocus on this camera, it's rubbish. Right, okay, there we go. So what we've done is, to be honest, this is why I sort of want to buy another thermal probe, because it'll save me having to do this. But basically, we've taken the bottom thermocouple from our motherboard, just taking it off, and basically what we're going to do is we're going to plug that into thermocouple position number 1, so into the first slot on the front of our rework machine. And I've just caught the pump button. So there we go. And then basically this is what this piece of tape is for. That basically means the thermocouple goes under this piece of tape. And then what you want to try and do, and this is tricky without knocking any balls off, is get a pair of tweezers and just pull the edge of that thermocouple just onto the bottom edge of that die. There we go, so that's now touching the surface of our die. Well, then what you want to make sure you're doing is, once that's in position and it's not going to knock into any balls or anything silly like that, manual profile settings on the Jovi. Now, as you can see there, that gives us our laser pointer, and we can see there now that our chip is going to be in the centre of our top heater. So if we go back to the Jovi, if you do use one of these machines, we'll show you what the crack is with this one. So we go back down to our control panel, as you can see there. So I said earlier on in this video that we were going to be using the manual control for this, and indeed we are. So what I'm going to do is I'm just going to swing our top heater down over the top of that chip. Now, earlier on we used position 4. Now on this one, I'm not going to lower the heater at all. I'm just going to swing it across and keep it right at the top. So I'm not going to move it down at all. It's literally sat up against the top of the clamp there, as you can see. So I'm not actually lowering this heater at all. I've literally just swung it over the top of the chip. And that is all I'm going to do with it. So that makes it nice and easy, because of course it's sat up fairly high underneath there, and if I can just lower you a little bit, you'll be able to see what I mean. We'll just raise you up, try and get you fairly level. There you go, you can see how that's fairly close anyway as it is, so we don't want to move it any closer than that. So if we just have a look again at our front panel here on the Jovi, we said earlier we were going to go through manual control on this machine, and indeed we are. So again, if you've got a different machine, even a different Jovi rework machine, this menu option is probably going to look slightly different for you. But we're going to go down to manual control, and then basically we've got options for our upper heater. That's the one we've just swung over. The middle heater is the middle plate on the bottom heater, and the side heaters are the left and right plates on the bottom heater. So we want to turn both of those off. So the middle and side heaters are going to 0%. That means those are off. Those aren't going to run. The only heating element we are going to run on this now is the upper heater that we've just swung over. Once we're happy with that, we can hit the OK button, and that now you'll see us turn to run. So if we just cycle up, and we can see now that the only thermocouple we've got connected is TC1, which is the yellow probe that we've just taken off the bottom of our PS4 board and popped onto the surface of our die there. that now will run. So you'll be able to see as this gets hotter, and we will just move our fume extraction into place over here. Right, okay guys, sorry for the jump cut, but the battery indicator light on this camera's flashing away at the moment, so I decided not to make you sit through the couple of minutes of just waiting for this to reach temperature, because there's not a lot to see in all honesty. So we're just about up to temperature now. You should start to see that these balls have all just started to sit nicely onto their pads, they're all nicely lined up. And we're up to temperature now, up to about 165, 170. So we're just going to swing this top heater away. And stop the process. As we can see there now, all our balls are nicely aligned and arranged, and that's all good. So just try and get you a closer look at that now. Just bear with me. Just going to take you out. As you can see there now, you just hit the cancel button to get rid of that laser pointer on there for you, and you can see now that all those balls are nicely attached to the chip and they're all in place. They're all perfect, and that's it. So that's now ready to go back on our clean board. So the next thing we need to do is get the board jig back up, and then we can go through how to realign the chip, and then ultimately get it reattached to the board. Right, okay, so welcome back. Now we've completely reballed the chip. All I've done off camera is I've rejigged the board, so I just put the board back on the jig table of the rework station, and I've also reattached the bottom thermocouple, which of course we removed in order to monitor the temperature of our chip during the reball. So I've reattached that, and then all I've done is just put this board back on the jig. I've also just given the Reball chip a quick wash in some IPA just to remove any old flux residue from the Reball, so that's nice and clean now as well. So what we've got to do now is we've got to move on to the reattachment process. So this is where we actually put the chip back on our board. Now, of course, earlier on we cleaned the BGA site with a bit of alcohol and a wipe, and as I say, our chip's nice and clean now too. So this is ready for the reattachment phase. So there's two things we need to do with this one now. We need to give the BGA site a coating in flux and make sure it's nice and even, and then we need to go and we need to realign our chip to the pads on the board. And then of course we need to run our reflow profile to actually physically reattach the chip to the board. And then of course we can cool the board, put the PlayStation back together, and cross our fingers and hope everything works. So without further ado, we're just going to get some flux here. And we're basically just going to use the same method as before. So we're going to give it a quick light brushing, and then we're going to just go over the surface with a card, with a plastic card, just to make sure that the coat is nice and flat and even, and that the excess isn't going to cause us any problems. So if you just bear with me while I do that. So like I say, you just want to load the brush up with a little bit of flux, and then just give it a quick coat in the middle, and then just drag that out to the edges. Just making sure you get every pad on the way down. Any excess, just get it on your brush and then just wipe it clean. And then, you know, just go over the surface like I said, just make sure you get every pad coated. Only light strokes. Blocking your view there, my apologies. So just light strokes across the board. And that is all you need. So what we're going to do then is we're just going to take our card, and then we're going to brush the surface of that just to make sure that we remove any excess. So I'm just going to move you to one side actually, so I was blocking you a little bit there. We don't really want to block your view. Try and get you some focus. The autofocus on this camera is weird because it does seem to focus and then once it's focused, it then goes out of focus and then refuses to actually go back despite the it's really weird. But a better camera is on my list of things. So hopefully it's not something I'll have to put up with too much of. So like I said, just get the straight edge of a plastic card, an old bank card, an old SIM card, that sort of thing. Keep the card nice and flat and just drag the flux over the pads. Like I say, you don't really want too much. You don't want a pool of it anywhere, you don't have any sort of ruts or runs of it. You just want a nice, flat, even coat across the board, coating all the pads. So all you want is the surface just to look wet. Just glistening slightly. If you've got that, you're perfect. And I can see in the light there, yeah, that's looking good to me. So we're happy with that. So I don't know if you'll be able to see in the light. We'll just try and take you off the tripod and see if you can see what I can see in the light. But you can see there. See how the surface of the board is just looking slightly shiny over the BGA sight there. That's perfect. That is exactly what we're looking for. Okay, so we've got our chip all fluxed up there now, and we just sort of get you back in there so you can see this. We're just going to align this chip up now. So I'm just going to take you off the tripod for a sec there, and I'm going to show you how we're going to align this. So as you'll be able to see in a sec, if you look right in the corners of the sight where the BGA is eventually going to sit, you'll see 4 large copper pads there. So I'm just going to point them out to you just in case you can't see that. And just by my finger there, and you'll notice that there's an identical one in each corner. In each corner of the chip, and there's also one just there, just at the tip of my glove. So you'll notice, as I say, there's those 4 there. So we've got our chip all fluxed up, and basically the 4 edges of the chip are going to sit over those 4 copper pads, and that's how we're going to line it up. Now on this board as well, you'll also notice that the pins on the underside a different pattern on either side. So if you split it down the middle, you'll notice that the pattern is different on this side than this side, which makes it nice and easy for us to guess the orientation of the chip. on the PS4, so it's fairly obvious which way around we're going to need to line this up. So I'm just going to put you back on the on the tripod there. And as I say, this is going to be fairly easy to do. So we're just going to make sure that the four edges of our chip are just going to sit nicely over those four pads that we showed you, that we pointed out. So, as I say, because of the orientation on the pads underneath, it's going to be easy to work out which way around that this is going to need to go. So I'm just going to put this chip on the old vac pump. And I'm just going to lower it into position, so roughly to begin with. There we go. So that's now roughly in place. And then I like to get the end of an old matchstick, or you know, you could use anything like an old cocktail stick, at the edge of a paintbrush, something like that, and just give the chip a gentle nudge into its final position. And as I say, you're just going to want to make sure that those four corners are resting nicely over the edge of those four pads. And they don't have to be exact, because surface tension between the balls on the chip and the pads on the board will pull it perfectly into position, as long as it's somewhere that's as long as it's somewhere close. You know, obviously if it's a million miles out, then that isn't going to work, and you're going to end up bridging pads and balls, and then you're going to have to take this off and redo the whole lot all over again, and that's no fun. But if you can get it somewhere close to begin with, and as I say, surface tension will do the rest for you. So we're nearly done here. We're nearly in position here. I'm quite happy with where this is. As I say, it doesn't have to be exact, it just has to be somewhere close. That looks close enough to me. So we're just going to take you back off the tripod, and I'll show you what I mean now. You'll be able to see what I mean when I say where we've placed this. You can see that now. Those four copper pads are underneath the four edges of the chip. You'll be able to see there maybe. That might give you a good idea there. So I'm just going to put you back on the tripod. Okay. Just bear with me a sec while I put you back on there. I'll try and get you some focus. The autofocus on this camera is woeful. Right, there we go. So all we need to do now is we need to place our top temperature sensor. As long as it's somewhere relatively close to the chip, and we're happy. If it's being a little bit stubborn, what you can do is get a little bit of Captain tape and just hold it in position with that. In fact, that's what I'm going to do. These rigid fixed temperature probes can be a godsend, and they can be an absolute nightmare. They're really good, and as such, as you know, you don't have to go laying them out and taping them down to boards, but occasionally they misbehave and they don't sit in quite the spot you want them to when they spring back, and you end up having to tape them down anyway. And today I can't be bothered with its games, so I'm just going to I'm going to tape it down. And I've just had one last quick check of the alignment, and that's all looking good to me. So, without further ado, just going to swing this top heater back over the top of the chip, and we're going to go back down to position 4 on the height scale on the Jovi there. There we go, that's all looking good. So I'm just going to lower you down a little bit so you can see what's going on. Hopefully as I do a few more of these I'm going to get a little bit slicker with the camera work, and with a slightly better camera, who knows what we might be able to achieve on this channel, but hopefully with the camera it will autofocus. I'd say it's a bit of a strange one because it does autofocus and then it goes too far, which is bizarre. But there we go. So what we'll do now is we'll go down to our Jovi. I'll just zoom you out there so you can see what we're doing. So on this one we're going to go into Profile Manager, and we're going to choose Profile. That's the one we used to lift the APU, of course, but this time we're going to use my second profile, which is a leaded reflow profile. So we're going to say OK to that. You can see this time the profile type is leaded. You're going to hesitate for 35 seconds at the peak temperature, which basically means we're going to hold it at the top temperature for 35 seconds. And as you can see, we're going to preheat at 120, we're going to soak at 180, peak is 195, and we're going to alarm at 190, and by that point we'll definitely know that the balls are going to be nicely molten. Now, as I say, this is really important, as I was saying earlier, that we ensure that the board is sufficiently supported and it doesn't sag and it doesn't bend and it doesn't move when we give it a quick press, because if this board does warp at this point when we're reattaching this chip, then we are going to end up where the chip will sit lower one side than the other. We may end up lifting pads, we may end up removing balls, we may end up merging balls and bridging things, and just generally making a bit of a mess, and we don't want that. So now is the time before you run this to, if you are in any doubt at all that your board is sufficiently supported, now is the time to do something about it. I'm happy that ours is, so I'll just go back up and we can see our GPU there, well, our APU even there. So what we're going to do is we're just going to run that profile now, and we're preheating, and I'm just going to give us a fume extraction. It's mightily important. And we'll revisit this in a couple of minutes once we're more or less back up to temperature. Okay, so we're just getting up to around the 160 degree mark here. So 170 we've just hit. So we're going to start to see this chip is going to sit in a sec. So I'm just using the light, and it might be worth it if you were doing one of these, just to get a little torch or something like that, so you can just see the underside of the balls. And what you're looking for is, you'll notice we're just hitting about 190 now. The balls will go shiny and they'll change shape, and the chip will start to move down towards the board. Once you see that, and we're just about there now. With a better camera we might be able to revisit this at some point and just show you that. We're happy now. So it's nice and uniform, it's nice and level, the chip's sat flat, it's not leaning to one side. The balls are nice and uniform in shape. We've hesitated the temperature long enough there to ensure that all the centre balls are nice and molten. So we're just going to lift the top heater away now. We stop the profile. And we swing the top heater away, which will allow the ball to cool. And that's looking really nice there now. So I've got no cooling on this at all at the moment, so we're not going to hit the cooling fans at all at the moment. The reason for that is because that chip is at nearly 200 degrees C. To hit the cooling fans and force the chip to come down at a rapid temperature may result in thermal stress to the connections underneath the chip that we've just made, which in long term will give us future reliability problems and may even cause a return of relay death. What we want to do is we want to allow the chip to cool naturally, certainly past its degree of, where the solder begins to melt. So as we can see there now, if we have a look at the Jovi, you'll be able to see what I mean. It's at 162, so at this point leaded solder is just about starting to reach its melting point, if you like. So it's just about starting to solidify now. And we want it to come down at, at a slow rate, so that temperature decrease needs to come down slowly, and that will ensure that the thermal stress to the joints is minimal. So you can see that's coming down by about 1 degree every 2 or 3 seconds. Which is what we want. So the only airflow over that at the moment will be the air that's pulled across by the fume extraction. There's no cooling at all from the rework station at the moment. It's to 145. What I normally do is just let the board get down to around 100 degrees and then kick the cooling in to reduce it back down to room temperature. Now occasionally you may hear a fan in a sec, and that will be the internal cooling fan for the rework machine rather than any cooling that you see to affect the chip or the reworked area. So you can see that that's sat there quite happily now. So yeah, once you, like I say, once you get a torch and you're approaching the sort of like 175, 180 degree mark, just get your torch and run it under the edge of the chip and get yourself down to eye level with the balls. And what you'll see is you'll start to notice they all go nice and shiny and sort of wet looking. And then what you're looking for is you'll notice that the chip will start to sit lower. So it will start on one edge usually, and then it eventually just flattens out. And the balls change shape. They go from sort of like a round profile to more sort of oval. And once you see that start to sit, hesitate for around another 10-15 seconds just to make sure that the centre balls underneath the middle of the die are sufficiently molten, and then you can stop the process. And we witness that. As I say, with this camera you wouldn't be able to get a good enough view of it, I don't think, but when we get some better equipment for filming this, we'll try and get a shot of that for you in a future video. But you get the idea. So that is now reattached to the chip. Sorry, the chip is now reattached to the board. I'm just giving it one final glance around the edges. And that's looking nice. So we're now at around the 116 degree mark. So in a sec we'll be kicking the rework cooling on. So the bottom temperature, the TC2 is the underside temperature of the board, which is 130 degrees. The TC1 is the thermocouple one, that's the top side fixed temperature probe we've got there. It's measuring the temperature at the top side by the BGA, that's currently 112, that's the one we're interested in really. So So once that gets down to 100 degrees, we're going to kick the cooling fan on. And then what we'll do is we'll join this board back at the table once we've sufficiently cooled it, and hopefully we'll be able to take a closer look at what we've managed to achieve today. Okay, so as you can see, there's our nice Reball APU sat back on our board. We've removed the Captain tape from the top and bottom sides of the board. Remember, we taped all these round blocks up. And we've also given the board a quick clean with some IPA on a brush. As I say, the best way to do this is obviously using a nice sweeping frequency ultrasonic cleaner, but as I say, he's on my shopping list of things to get. Unfortunately, it's not something I have at the moment, so a brush and some IPA, you know, in a good 10-15 minutes of your time, just making sure you get everything nice and clean, and run some IPA under the chip. Just to flush out any sort of old flux residue or anything like that, will suffice for now. So, as I say, that's all looking nice and clean now. The underside, again, you know, remove any Captain tape, any residue that's left over from that. Again, just make sure you remove it, because ultimately you want to make sure that this board is as close to factory as it was when you started, because of course the closer you can get it back to factory, the better your results are going to be. Some fluxes can be corrosive to tracers, and motherboard sort of copper and layers and things like that, so it is important that you remove it as much as you can. So as I say, we've cleaned this chip up now. We've given it a quick coat in some IPA. We've run a little bit of thermal interface cleaner over the top of the die there to prepare it for receiving some new thermal paste. If you have a quick look around the edges, I don't know if we'll be able to sort of show you much of this, but we'll try. As I say, I don't know how well this camera's gonna take this, but we'll give it a go. So as you can see, there's our die there, all situated back in place. So what you don't want, of course, is you don't want to see any lumps or bumps on the surface of your chip. Once this is back in place, it wants to look nice and flat and solid, and that one looks perfect. So I don't know if you'll be able to see much of the underside of this. Maybe if I get a light on it, you might be able to see a little bit more. Kind of. See, that's sat nice and flush to the board. It's probably not the best angle to get because the RAM blocks are in the way. See if we can spin it around and give you a slightly better view, maybe. Yeah, you can kind of see there that the chip is nice and flat, and it's sat level with the board, you know, and everything looks good there. So as I say, our board's nice and clean. Captain tape is removed, so this is now ready for reassembly, and then we'll fire it up and we'll see what sort of result we get out of it. And hopefully, we've got a working board and a working console. And if you've been following along at home, and you want to try this, and hopefully you will get the same result. So we're going to reassemble this machine now, and we'll give it a test, and we'll join you back downstairs for the big switch on. Right, okay, welcome back. Whilst off camera, what we've done is we've reassembled the PS4. So we've put the motherboard back in, we've reassembled the console completely, put all the screws back in. I've connected the HDMI back up to the machine. So what I will do now is just give you a little bit of advice, really. Now sometimes, depending on the nature of the blue light that you've had, if the machine was on at the time and it was writing to disk, it does have the potential to have corrupted the system software. which if it does, upon the first reboot, rather than sort of like it behaving normally and going into the OS, you can get it where the machine will attempt to boot, fail, reboot, and boot into safe mode. And it will ask you, it will basically say that the console can't start, and it will prompt you to reinstall the system software. So, just in case you do get that, I basically keep a little USB stick handy, and whenever a firmware update comes out, I make sure that I download it and just drop it on here, and then I've always got it to hand, just in case this happens on a machine that we've fixed. Now, I'll be honest, more often than not, these machines go back into the OS without too much fuss, but I have seen one or two that do go back into safe mode. It's not a big thing, like I say, it just means that the system is writing to disk at the time it failed, and like I say, occasionally that does corrupt the system software, and you have to reinstall it. So, like I say, before you do this, it might be an idea just to get a USB stick and download the latest firmware from Sony. Then you've got it just in case. You're best off downloading the full system software, so the 700 or 800 meg version, as opposed to the cumulative update, which is about 200 or 300 meg. Both are available for free from PlayStation.com. At the time of this video, we're on software version 2.57, so that is what's on this stick. So I've got that ready just in case we need it. But hopefully this is going to go into the system software and we can call this fixed. So what we'll do without further ado is I'll take the power lead. So I haven't plugged this in, I haven't fired it up, so this is new to me as it is to you. The monitor is on, I've turned that on already, that's what the red light is flashing out from down there. If we can get the power plug in, there we go. Okay, so power lead is on. So let's hope that what we get now is a little bit more life out of this than what we had before. So I'll just try and zoom you in a little bit there. There we go. Okay, so what we will do is we will hit the power button and hope that we get some sort of sign of life out of this. So before we powered it up, we got a blue light for a couple of seconds and then the machine powered off. So we disassembled it, we've shown you the reballing process of the APU, we've reassembled it, and now we're back at this stage. So this is the big switch on. Hey, that's looking a little bit more promising. So we'll keep an eye on the display and we'll just see what happens. So we go to a white light. Now put it to the display, so we'll just there we go. So just switch the input on the display there, and as you can see, we go straight to safe mode. So that's not looking too good, is it? So cannot start the PS4. Connect the DualShock 4 using the USB cable and press the PS button. So we do have some sort of sign of life, but as I said before, and this is, to be honest, I'm quite pleased that this has happened, because this just shows just why you should always keep something like this handy if you're fixing these. Because otherwise I'd have had to go away, spend the next 5-10 minutes downloading that. It's all a bit of a pain, isn't it? So I'm just going to connect the controller to USB to port 2, because the USB stick wants to be in port 1 ideally. So I'm going to hit the PS button and we'll sync there. So connect to USB storage device that contains an update file from installation. Oh, version 2.03 was this particular machine. So we've got 2.57 on there, so it's the latest version. So this will reinstall the OS and update the firmware at the same time. So we'll go to OK and confirm with X. And this will go away now, and this will want to format the hard disk. So what it's doing when it's sat in the please wait mode is basically it's checking the USBs for a valid firmware update file. And as I say, because this is the full 700 or 800 meg version, it will do a checksum against it to confirm that the image is valid before it installs. So that's going to take some checking. So you know, it usually just spend a couple of minutes there just saying please wait. So don't get impatient. Don't think it's crashed. Don't think it's not doing anything. Just leave it be. It will sort itself out. just while we're waiting for that, actually, we'll just go through a few things, actually. And my mate has just dropped me his PS4 around. He's having some issues with it. He says, and I haven't checked this yet, he's literally just dropped it off camera, and he basically says that the machine powers up to a blue light, usually knocks itself off after a couple of seconds until he plugs a joypad in. Once the joypad is plugged in, he says it starts up and goes into the OS. He says until he puts a game in, and then it turns itself off, which is all a little bit interesting. So I'm not entirely sure what's going on there, but I said I'd have a look for him, so it gives us something interesting to look at. And that's actually just led us nicely up to this. So as it'll say, PS4 will be initialised. That's basically a fancy way of saying we're going to format the disk. So everything's going to be deleted. Sure you want to continue? Yes. Now you don't have much of a choice about that. If this happens to you, unfortunately you are going to lose everything on the hard disk. If you have a valid PlayStation Plus membership and you've got your game saves backed up to the cloud and everything else, then of course you can re-download those once you're back into the OS. Yes, it's a little bit inconvenient, but at least you won't have lost anything. If you don't have a valid PlayStation Plus subscription, then unfortunately you are sort of up creek without a paddle. And you are going to lose everything, but there's not a lot you can do about it. You know, you can either have a working PlayStation or your data. So, as annoying as it is. So, as you can see, we've done a quick format of the disk, and now it's preparing to update the system software. So that's copying the update file from the USB to the local storage, and the machine will then probably reboot itself, perform a firmware upgrade, reinstall the OS, and hopefully after a further reboot we should end up in the OS with a working machine. So we'll just leave that be for a moment. And the key here to this process is not to get itchy feet. So don't panic if things don't look to be working the way that you would hope they are. You know, if you're thinking it's taking a little bit long to do something, then don't worry about it, just let it do it. It is behaving, it is going to be okay. So at this point the system is copying the firmware to the local disk before it shuts down. So it does take a slightly longer amount of time than usual to complete this step. So don't panic if it's sitting there flashing blue lights at you for a couple of minutes, because it's quite normal. But yeah, while we're waiting for that, just back to the next video we've got coming up. That should be quite an interesting one. I'm not entirely sure what the background is. My mate hasn't said much on it. He hasn't mentioned much about how or why or in what context this machine suddenly started behaving in the way that he says it has. So we'll just have to see what gives. That video is the next one that's coming up on this channel. To be honest, I'm not entirely sure if there's going to be a lot we can do with it, but I thought it would be an interesting one to look at nevertheless, just in case there is something we can do for him. Okay, so the system has just powered itself off. As I say, on the initial software installation like that, when you're doing a full system restore, can and will take a little bit of time to shut down and start back up. Don't worry about it, it's perfectly normal. Just switch the input on my monitor because there we go. For some reason these monitors default to HDMI 1 whenever any source that you are watching quits out, so you can sit there looking at a blank screen for a while. So there we go. So as you can see, we're going to the United Kingdom. So next. I'm going to do that later. I'm going to do that off camera. I don't want you guys to see my Wi-Fi password. Date today is the 14th of August 2015. The time I'm not too sure about, so just skip through this. And there we are. As you can see, we're back in the OS now. And if we go down to settings and we have a look in system and system information, you can see now, look, that we are on system software version 2.57, and that we've no games or any shortcut tiles on there, so any data that we had on there is completely lost. We'll just confirm that. We'll go into system storage management, and as you can see there, we've got the full disk available to us with 408.4 gigabytes of free space on this 500 gig model. So that is that, and as you can see, we are good to go there now. Just remove our USB. We'll remove the USB from our controller. You can see that it's still synced up there, so that's all good, and we can still work. And there we go, so we'll just shut the machine down. Okay, then we'll start the machine back up. And I bet the input on my monitor switched itself back again, hasn't it? Because it always does. I don't know why it does it, but it does. There you go. So just press the PlayStation button on the controller. User 1. Too bothered about PlayStation Network at the moment. And there we go. So we can call that fixed, and we'll see you on the next vid.